Hey guys, it's April 20th. We're still starting out with chapter 8 here. So today we're going to be talking about the Pythagorean theorem. So we've used that before in the distance formula. Now we're going to use it and we're going to learn about the converse of it. So some new vocabulary is a Pythagorean triple. We've talked about it a little bit in class before and we've used it in some proofs, I think, but now we're going to use it in some different ways. So the definition of that is a set of three non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. And there's some pairs that go together, or triples that go together, and we'll talk about those in a little bit. So here's the Pythagorean theorem. We've used this a lot, so you guys should know this. So we have a squared plus b squared equals c squared. Remember that c is always the hypotenuse, so it's that longest length. A is typically the shortest length that's adjacent to that right angle, and then B is typically the longer length that also makes up that right angle. Here's a proof of it. I think we've done this before. It kind of derives from the distance formula, or the distance formula derives from this. We won't spend a ton of time on it, but this is in your textbook if you want to take a look and dive a little deeper into this. So here's our first example. We have to find the missing measure. So in this case, we're finding x. Okay, so first we have to determine where the hypotenuse is, and that's always opposite from the right angle. So x is our hypotenuse, so we're going to call that c. Okay, 4 is our shortest length here, so I'm going to call that a. 7 we're going to call b. And a and b, when we put those together, they create that right angle. So off to the side here, if I had a squared plus b squared, we would have 4 squared plus 7 squared equals this c, which we're going to call x squared. Okay, I think this actually solves it out for us here. Yep. Okay, on the next page we're going to go through and we're going to simplify this 4 squared and 7 squared so that we get 65. And we take the square root of each side because we're looking for c, which was that x, and we get the square root of 65. So c, or that value for x, I don't know why I changed it to c, but x equals square root of 65. Okay, here's another one. Now notice we're not finding the hypotenuse, we're finding one of our side lengths. So the order that we put things in is going to be a little bit different. So 12, that side is our hypotenuse because it's opposite of the right angle, so that's our c. Now this x looks a little bit shorter than our other length, so I'm going to call that a, and then h would be b. So when we start plugging things into the Pythagorean theorem, we have x squared plus 8 squared equals 12 squared. So when we solve this out, we get the 64 here and 144 over here. Now we want to solve for that x. So when we subtract it over, we get x squared equals 80. Now when we take the square root of 80, we can actually simplify it. So we want that answer, not just square root of 80. We can simplify it down to 4 square roots of 5. So our value for x in this case is 4 square roots of 5. Okay, pause your video here. You guys can work this out at home. Okay, here we're trying to find the hypotenuse because that's the opposite of the right angle. So we can go ahead and plug it in. I'm going to call this 5a, 8b, and this x is our hypotenuse, so that's always c. So if I go ahead and plug that in, I get 5 squared plus 8 squared equals c squared, we'll say. Okay, simplify these out, we get 25 plus 64 equals c squared. Add these numbers together, we get 89 equals c squared. Take the square root of both sides, so c is equal to the square root of 89. So you guys should have gotten answer C on this one. Okay, now on this next one that you guys are going to do at home, we're solving for one of those side lengths instead of the hypotenuse. So when we go ahead and plug these in, okay, now our hypotenuse is c. I'm going to call this 6a, and I'm going to call this xb because it looks like it's our longer side. So when I go ahead and plug those into the Pythagorean theorem, We have 6 squared plus b squared equals 12 squared. Oops. Okay, now when we go ahead and solve these out, we get 36 plus b squared equals 144. Okay, we're solving for that b, so we have to subtract the 36 over, so I get b squared equals 108. Okay, and we take the square root of that. It's going to give us root of 108. Okay, but those can be simplified. So when we simplify that, I can't do that in my head right now, we should get b. So we should get 6 square roots of 3. Mr. Knutson's in the back making me laugh, guys. Okay, so here's some Pythagorean triples. So these numbers, when we plug them in for a, b, and c, they will always be equal, with the a squared plus b squared equaling the c squared. So in this case, our 3 and our 4, if we square both of those and add them together, will equal 5. And notice we're just doubling each of those numbers, or adding another 3 and another 4 and another 5 to make these bigger triangles, but they're similar triangles. And these also work. So let's just jot these down on the sideboard so we remember them. So we have 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, and 25. Okay, so we're going to apply those in here now. Okay, so we have to use a Pythagorean triple to find x and explain your reasoning. Now this 24 and 26 might have been in that list, but what we can do is we can simplify it down to smaller numbers. And if we have 2 of these numbers, then we know what our third one's going to be. That's the neat thing about the triples. Okay, so I'm seeing that both of these numbers can be divided by 2. So let's divide them by 2 at first. So if we divide 26 by 2, we get 13. If we divide this by 2, we get 12. Looking over here, we have a 12 and a 13. That 13 is the biggest number in the triple, being the hypotenuse. So this x right now must be 5. But x isn't just 5. Remember, we made the triangle smaller by dividing by 2. So to find what x actually is, we have to take this 5 times 2. So then x would equal 10. And now, of course, this is going to go ahead and solve it out for us, but we did that on the last page. Now to check it, we're going to plug in those numbers. So the 24 squared plus 10 squared, does that equal 26 squared? We go ahead and solve it out and we get 676 on each side, so it does work. Okay, here's one for you guys to try at home. So it looks like both of these numbers can be really easily divided by 3. So let's try that. So divide this by 3, we get 12. Divide this by 3, we get 13. So it's using that same triple that we used in the example before, so we know that this side will be 5. Okay, but it's not just 5. We made it smaller, remember, so now we have to go back to the original numbers and make it bigger. So first we divided by 3, so now we're going to take this 5 times 3. So the answer that we should be getting is b, x equals 15. Okay, so now here's kind of a real-life situation where we might have right angles. So we have a 20-foot ladder being placed against a building to reach a window that is 16 feet above the ground. How many feet away from the building is the bottom of the ladder? So we're given this 20-foot-long ladder. Okay, and this building, the wall is 16 feet, being the window up here. Oops. Okay, and we want to know how many feet away from the ground is the ladder. And so this gives us a couple options. It could be 3, 4, 12, or 15. And we're going to use some Pythagorean theorem and triples to figure that one out. So we read the test item, we understood the problem, we kind of know what's going on. Now to figure out how to solve it, there's kind of two different ways. One, we could use the Pythagorean triple. So we're going to go ahead and do that. So when we divide, let me just go back. Using the first method with the triples, okay, we want to reduce those numbers so that we have one of these, hopefully. Okay, well, 20 and 16 I can divide by 2, or I could divide by 4. If we divide by 4, that'll give us the smallest numbers possible. So 20 divided by 4 gives us 5. 16 divided by 4 gives us 4. Okay, 5 and 4 over here, looks like I can use this top one, so that x equals 3, but remember we divided by 4, so we have to multiply by 4, so that x equals 12, so this ladder is 12 feet away from the building, and that's what this first method is telling us, is that we get C, answer 12. Okay, or method 2 is using the Pythagorean theorem, where we have our C, 20, because that's the ladder, that's what the hypotenuse is, and then our longer length is 16, that's what the height of the wall is. Go ahead, solve that out. We get x squared equals 144. Take the square root of both sides, so we get x equals 12. So no matter which way you want to solve it, you still get the same answer. So it's kind of whichever your preference is. Okay. So here's another one for you guys to try. It's the same kind of concept. It's probably helpful to draw a little picture on your paper when you're solving these so you know what's going on. So now we have a 10-foot ladder being placed against a building. So let's just draw a picture. So here's my wall, okay? Here's my ladder. It's not drawn to scale. I don't know how far away it is yet, but I know that this ladder is 10 feet, okay? And now it's telling us that the base of the ladder is 6 feet from the building. So this distance right here is 6. Okay, so now it wants to know how high does it reach on the building. Okay, again, there's kind of two different ways that we could do this. I'm going to use the triples because I think that's kind of easier. I'm going to divide each of these numbers by 2. I'm going to put a little question mark there because we don't know what that is. If I divide this by 2, I get 5. Divide 6 by 2, I get 3. Oops, why did I write 5? Okay, 5. So our hypotenuse is 5, one of our legs is 3. Over here, using this triple, this side length must be 4. But remember, we made them smaller, so we have to make them bigger again. We divided by 2, so we have to multiply this 4 by 2. So it must be 8 feet tall on the building. Okay, and if you use the Pythagorean theorem and plugged in a squared plus b squared equals c squared, you would have gotten 8 as well. Okay, so now here's the converse of the Pythagorean theorem. So now we're saying if a squared plus b squared equals c squared, then triangle ABC is a right triangle. So it's just backwards from what we've always known. Okay, now here's a couple new concepts that maybe we haven't considered yet. So the Pythagorean inequality theorem, so this 8.6 is saying if c squared is less than a squared plus b squared, then triangle ABC is acute, like this one drawn over here. Okay, now this one's saying if c squared is greater than a squared plus b squared, then triangle ABC is an obtuse angle. So these are probably some theorems that would be helpful to write down because we're going to use them in a little bit. Okay, so here we have to determine whether 9, 12, and 15 can be the measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. Justify your answer. Okay? So step 1, we have to determine whether the measures can form a triangle using the triangle inequality theorem. So we're going to go ahead and plug them in. So notice we had 9 plus 12 equals 15. Not equals, sorry, is greater than 15. And that's true. So 2 of our legs added together is greater than our hypotenuse, or the longest leg, not the hypotenuse, the longest leg. Okay, when we take 9 and 15, that's greater than 12. And we take 12 and 15, that's greater than 9. So that's the first step that we have to check. Okay, so that can form a triangle. Now step 2 here, we're classifying the triangle by comparing the square of the longest side to the sum. We're just applying it into the Pythagorean theorem or inequality. Okay, so we want to know, is c squared equals to a squared plus b squared? So we go ahead and plug in 15, 12, and 9 for those sides. And we get 225 equals 225. So since they're equal, then this triangle is a right triangle. Okay, now we're going to try another one. So now we have side lengths 10, 11, and 13. Can these be the sides of a triangle? If so, classify the triangle as acute, right, or obtuse. So step 1, we're going to check those sides. So when we do that, we have 10 and 11 is greater than 13, 10 and 13 is greater than 11, and 11 and 13 is greater than 10. So we're just checking those sides. So those look good. They can form a triangle. Go into step 2. Now we're going to plug these in for A, B, and C. Now we're going to see, are they equal? So we plug them in. Now we get 169 is less than 221. So now we have to refer back to those theorems and say, okay, is this giving us an obtuse angle or is it giving us an acute angle? And so since c squared is less than a squared and b squared, then the triangle is acute. Okay, here's one for you guys to try. So we're given the set of numbers 7, 8, and 14. Okay, and we have to figure out if it is a triangle, and then if it is, if it's acute, right, or obtuse. So first step, we have to check the side lengths. So we have 7 plus 8 greater than 14. Here we get 15, so that one looks good. Okay, we're going to take 7 plus 14 being greater than 8. We get 21, so that checks out. And now we take, which one am I missing? 8 plus 14 greater than 7. Yep, that checks out. So these side lengths are for a triangle, so we're just going to scratch out option D because we know that it is a triangle. Okay, and now we go ahead and plug it into the Pythagorean theorem to see if they're equal, less than, or greater than. So we have 7 squared plus 8 squared equals 14 squared. And I'm going to put a little question mark next to my equal sign. So here I get 49 plus 64 equals 14 squared. What's 14 squared?
196.
Thank you. Equals 196. Okay. When we add these together, we get 113 is less than 196. So we're getting that, yes, they are a triangle, and since the c squared is greater than the combination of a squared and b squared, it's an obtuse angle. Okay, here's another one for you guys to try. So now we have side lengths of 14, 18, and 33. So we're going to first step, go ahead and check if we can make a triangle. So I have 14 plus 18 is greater than 33 on this side. Wait a minute. This gives us 32. And that's not greater than 33. So right off the bat, we know that it's not a triangle since that's not true. So if we ever have any two sides that are not greater than the third side, it's not a triangle. And that's why we have to check to see if these side lengths work or not. Okay, so here's your assignment. We're going to do page 552, 9 through 41. Hopefully it's pretty easy since we've used the Pythagorean theorem a lot. We have some new concepts. Let us know if you have any questions on it.